Properties of exponents. We're going to review a bunch of properties today, and it will take probably having to come back to this a few times and taking some good notes to remember them all. All right, so properties of exponents, a quick review, some special exponent properties. The zero exponent, any non-zero number raised to the power of 1 the power of 0 is 1. So for instance, a to the 0 is 1, or if I move down here to these simplified ones, 3.9 to the 0 is 1. It's always 1. Okay. Any integer raised to a negative power is equal to 1 over that integer. So it becomes, we think of this, we put a 1 under it, and this whole thing would move down. It switches sides, so we get 1 over a to the n. So if I, for instance, move down here, x to the negative 4, this just moves to the other side of the fraction. It's not the reciprocal, it just moves to the other side. 2 stays down there with it. So we vacate the top and we make it x to the positive 4. So the negative means it changes sides, and we make it positive, the exponent positive there. Okay, and the 2 stays down there with it. So we actually have 2 times x to the 4th, and then on the top we'll put a 1. Okay, because we have to have that place value holder. Okay, so 1 over 2 x to the 4th. All right, so let me kind of explain why that works really quick. I'm going to do this on this screen here. So if you think of, for instance, let's go with powers of 2. We know that 2 to the 3rd power is 2 times 2 times 2, and that is 8. 2 to the 2nd power is 2 times 2, and that is 4. 2 to the 1st power is just 2, and obviously that's 2. And you start seeing a pattern here. You know, to go to 8 to 4, we obviously divide by 2. That's because there's 1 less 2. You go 4 to 2, we divide by 2. Once again, 1 less 2 we're multiplying by here. And so to actually get the next one, which is actually 2 to the 0, we divide by 2, which 2 divided by 2 is 1. And in fact, like if these were 3's, we would be dividing by 3, and you get 3 divided by 3, which is 1. Or if it was 3.9, we'd divide by 3.9, and you get 3.9. 3.9 divided by 3.9 is 1, so you always get 1 there. What's interesting is you continue this pattern. So rather than 2 to the 3rd, 2 to the 2nd, 2 to the 1st, 2 to the 0, we can now go 2 to the negative 1st. And we continue this pattern. Okay, well, 2 to the negative 1st, we just divide by 2. So 1, take that 1 and we divide it by 2. Well, that's 1/2. Okay, and then we go 2 to the negative 2nd. Well, we take that 1/2 and we divide that by 2. Well, 1/2 of 1/2 is a 4. Well, another way of writing, well, actually, let me get to this next piece and then we'll do it. Next one is 2 to the negative 3rd, and we'll divide that by 2, which is 1/2 of a 4th, which is actually an 1/8. Now, another way of writing a 4th, we could write 1/4 as 1 over 2 to the 2nd. And another way of writing 8, note, 8, another way of writing that is 2 to the 3rd. So we could write this as 1 over 2 to the 3rd. So these negative exponents, really what's happening is you just put it in the denominator. So it's 1 over 2 squared, 1 over 2 to the 3rd. And that's how we have with those negative exponents. Okay, so trying some of these out, the negative 5 to the 0 power, anything to the 0 is 1. 3x to the negative 4th all over 2. One thing that's important here, the only thing being raised to the negative power is the x. So that piece is being raised to the negative. The 3 isn't, so the 3 is going to stay on top. The x is going to move to the bottom, and the 2 is not being raised to the power, so it just stays there as well. So 3 and 2 don't move. Okay, and so looking at this next one, well, the 3 and the 2, they don't move. They're not being raised to a power. The x to the negative 4th is, it has to go down. In fact, if something's on the bottom, the denominator, and it's being raised to a negative, it actually moves up. It changes sides. So the y to the negative 5th moves up and becomes y to the positive 5th. The x to the negative 4th moves down and becomes x to the 4th. Notice I keep adding a piece. So each time on these problems. So now I'm here. Well, no, the thing that doesn't move is the 3. It's not being raised to a power. The 2 actually has a power now. It's 2 to the 0, and 2 to the 0 is 1, so I'm just going to cross it out. Because multiplying by 1 doesn't change anything. The x to the negative 4th moves down. The y to the negative 5th moves up. So on top, I have 3y to the 5th. On bottom, that x to the 4th. All right. And this last one here, well, taking a look at it, everything's raised to a power this time. The 3 is to the negative 2nd, so it's going to move down. The x is to the negative 4th, so it has to move down. The y is to the negative 5th, so it has to go up. And 2 is to the 0, so it's just 1. So what's on top? Well, y to the 5th is up there now. What's on bottom? Well, 3 to the 2nd and x to the 4th. And we've got to simplify that. 3 to the 2nd is actually 9. So we've got to call it 9. And x to the 4th. All right. Well, there we go. We'll keep talking about those negative exponents. They're going to pop up a lot. Okay, some other properties. The product of powers property. So I'm going to show you the rule, and then I'm going to give an example here. So that just says a to the nth power times a to the nth power is a to the n plus n. So in other words, if I use 2, for instance, 2 to the 3rd power times 2 to the 2nd power. Well, if you're not sure, write it out in an expanded form. Expanded means a long way. So what does 2 to the 3rd mean? It actually means 2 times 2 times 2. What does 2 to the 2nd mean? Well, it means 2 times 2. So when I'm done, I have 2 to the 1, 2, 3, 4, 5. That's 2 to the 5th. So the shortcut, rather than writing it out the long way, is just say, hey, 2 to the 3 plus 2, which is 2 to the 5th. It's supposed to be a plus there. All right, quotient of powers, kind of the same idea. It's just that now you're dividing. A to the m divided by a to the n, you go a to the m minus n. So if we use our 2's in an example again, and just say now I have 2 to the 3rd, and let's make it so it's not looking like we're doing the same problem there. Okay, so if I have 2 to the 3rd, and I have 2 to the 2nd, that's the same as having like 2 times 2 times 2 over 2 times 2. All right, and that would mean that, well, this 2 would cancel that 2, this 2 would cancel that 2, and I'd just be left with 2. 2 to the 1st, or 2. The quick way, well, the quick way is just say, well, let's go 2 to the 3 minus 2. Just subtract those 2. Subtract the top power from the bottom. As long as the bases are the same. Notice the a's are the same, the 2's are the same. Like this was 2 to the 3rd and 3 to the 2nd, you couldn't do it because the base, the big number is different. Okay, that's kind of the shortcut there. Okay, power of power property. This says a to the m times, or to the nth power. So a to the m to the nth power, you're multiplying here. So once again, what that actually means, if I have 2 to the 3rd power, and I am squaring that. That's kind of the idea. Well, this 2nd power squared means I have 2 of these things. So that really means I have 2 to the 3rd times 2 to the 3rd. And we know that 2 to the 3rd times 2 to the 3rd means 2 times 2 times 2 times 2, which is 2 to the 6th. Well, the quick way of doing that then is just to say, well, I could just multiply those two. That'd be like having 2 to the 3 times 2, which is also 2 to the 6th. Okay, so just some shortcuts to help us out. All right, let's try to apply some of those there. So simplifying each expression, write your answer and using only positive exponents. And I actually have a quick reminder there. Just a quick reminder, negative 2 to the 4th power, negative 2 to the 4th. Anytime a negative is outside of parentheses and you have a power after a base then, the negative isn't being raised to the 4th. This is like having negative 1 times 2 times 2 times 2 times 2. Okay, So it's 2 times 2 times 2 times 2, or 16 times negative 1. So this answer is negative 16. Whereas this answer, this says negative 2 times negative 2 times negative 2 times negative 2. So if the negative's in parentheses, it's being raised to the fourth power. Okay, so that's negative times negative is positive, times negative is negative, times another negative is positive, positive 16. So note the differences there. Okay, so make a note to yourself. Hey, if the negative is not included in parentheses, then it is not being raised to that power. Okay. All right. So let's go ahead and simplify each expression using positive exponents. So 4 to the third and 4 to the fifth. Well, we have 4 to the, since the same base, we keep the base and we add the exponents, which is 4 to the 8th. Okay. And it says write it as integer. So here's one answer using the positive exponents. And then writing that as an integer is 4 times 4 times 4, 4 to the 8th, which is 65,536. All right. The next one, same base. And we're now going negative 3 plus 5. Well, negative 3 and 5 is 2. That's 4 squared, which is 16. So there it is as a power, and we've got it as an integer there. Okay, notice our bases here are negative 3, and they're in parentheses. And we are subtracting, so top minus bottom, 2 minus 5. So that gives me negative 3 to the negative third. And I can only use positive exponents, so I can't leave it like that. Remember, the negative means if it was a fraction, which we just put a 1 under it, that whole thing moves. So now I have on the top just a 1, that place value position, and then negative 3 to the positive third. Okay, well there it is as a power. And negative 3 times negative 3 times negative 3, well that is negative 27. So there it is as our integer. Okay, or our evaluated amount there. Okay, please note on this one, this is, the negatives aren't in parentheses, so this is the same thing as having negative 1 times 3 squared over negative 1 times 3 to the fifth. Well, negative divided by negative 1, those cancel. So I'm now left with 3 squared over 3 to the fifth. And that, since those are the same base, that's 3 to the 2 minus 5, which is 3 to the negative third, which is, once again, 1 over 3 to the third, right? Kind of just like this. And that is equal to 1 over 27. 3 times 3 times 3. All right, a power to a power. So this says I have 2 of these, so I'm going to double it. Okay, so I have x to the negative 4 times 2, which is x to the negative 8. And we're going to make it into a fraction and move that down. That's 1 over x to the positive 8. Okay, and this last one here, again, we're multiplying them. Okay, so we have x to the negative 4 times negative 2. Put them in parentheses just because there are negatives with them. So negative times negative is positive. So x to the positive 8. We're done there. Alrighty. Well, 2 more properties here. The next property says power of a product property. So AB to the nth power is the same as A to the m times B to the m. So really what you're doing here is you're distributing. You have 2 things being raised to, 2 different things being raised to the same power. So you can distribute it. So for instance, if I had like 2, and I'll use a variable with it, 2x all to the third. Well, that would be the same as having 2 to the third and times x to the third. Okay, and similarly, if you're dealing with a quotient, it goes in. So it's like using the distributive property. If I had, say, 2 over x all to the third, that'd be 2 to the third over x to the third. All right. So that's power of a product and power of a quotient. Let's apply those in with some of our other stuff here. So negative 2.5 times x, all the quantity squared here. So I am going to, since the negative's in there with it, I am going to take and square that, and I am going to square this. So I get negative 2.5 squared times x squared. Well, negative 2.5 times negative 2.5 is a positive 6.25, and x squared can't be simplified anymore. So there we've got it. So we distribute the negative 5 in here. That gives us 10 to the negative fifth and x to the negative fifth. So this is one way to do it, okay? And then looking at that, you notice that they're both negative, so we would want to bring them down, like so. So we now have 1 over 10 to the fifth, x to the fifth. And 10 to the power 5, anytime you have 10 to a power, all you do is write a 1 followed by that many zeros, so 5 zeros. That's actually multiplying it out there. That gives 100,000 and x to the fifth. So 1 over 100,000 x to the fifth. Now some people would teach this where you just take the reciprocal right away. So immediately before you even distribute it, you could say, well, that's going to be 1 over 10x to the fifth power, and then bring in the 5. I did it the other way. Either way works. Okay, the next one, we'll bring in the 4 there and there. So we get x to the fourth and negative 10. Note the whole thing is being raised to the fourth because it's inside the parentheses. So when I distribute it, I'm putting negative 10, I'm putting the 4 on the outside like that. That's important because a negative times a negative times a negative times a negative actually gives me a positive. Actually, let me write this down below here. That gives me a positive 1 with 4 zeros, 10,000, and then x to the fourth on top. All right, the next one we'll bring in the cubed to the 4. We get 4 cubed. To the x, we get x cubed. And to the 3, we get 3 cubed. Now, I go through these quick, but remember you can pause and try them on your own there. 4 to the third is 4 times 4 times 4, or 64, x cubed. And 3 to the third is 3 times 3 times 3, which is 27. You'd always want to try to reduce the numeric part, 24 or 64 27ths, but it doesn't, nothing goes into both 64 and 27, so we're just done with it there. Okay, this next one, notice it's a fraction being raised to a negative. So since the whole thing's being raised to a negative, that means each one of these terms is going to be negative. If it's a fraction being raised to a negative, the first thing I do, since the whole thing's being raised to a negative, I just flip it. So I put the 2 on top and the 3y on bottom. And by doing that, it now makes that 4 positive. Okay, so make a note of that there. If that's a negative and it's a fraction, you just flip it. Okay, so now I have 2 to the 4th, not 24, 2 to the 4th over 3y to the 4th, or 3 to the 4th and y to the 4th. So 2 to the 4th, 2 times 2 times 2 times 2 is 16. 3 to the 4th is 81, and y to the 4th. All right, there we got it. Okay, the last thing I have today for us is scientific notation. So a really quick note about scientific notation, if you're not familiar with it. Scientific notation, you start out with a number between 1.0 and 9.999 and so on. It has to be in between 1 or greater and less than 10. And then we're going to multiply it by 10 to a power. Okay, it's scientific notation used for really big or really small numbers in science there. So this is scientific notation. So like 4.2 times 10 to the 7th, the number's between 1 and 10, and it's being multiplied by 10 to a power. That's scientific notation. When it's saying convert to standard form, well, standard form just means like normal form, like the normal numbers we usually see, like down here, 3,624,000,000. That's standard form, or 0.0000326 or 624. You know, that's standard. Okay, so I'm going to go from scientific to standard. And some people teach, well, if you move this way, or if you have a positive, you move to the left, it makes our power greater, or makes it negative or positive. I'm not going to talk about which way I move, other than, or rather than, I'm going to talk about the power. So this is a positive power, 10 to the 7th. So since it's a positive power, it means I'm going to take my 4.2, and since it's a positive power, my number has to get bigger. Okay, bigger by a factor of 10, 7 different times. So when I multiply by 10 once, I'm at 42. Twice, I'm now at 420. 3 times, I'm at 4,200. 4 times at 420,000, or excuse me, 42,000. And then 420,000. So I'm at 1, 2, 3 power, 4th power, 5th power, 6th power, and 7th power. So my solution here to go to standard is 4, 2, and then I have 1, 2, 3, 4, 5, 6 zeros. All right, there we've got it. 42 million. All right. Well, if I have 4.2 raised to the negative 7th, well, notice that the negative power now, that means my number, 4.2, is actually going to get smaller. It means I'm actually like dividing by 10 7 times. So 1, 2, 3, 4, 5, 6, 7. So my number gets smaller. So I started with 4.2, so it has to get smaller, so I'm got that there. And I always put a leading 0 there. Okay? So really, if I write that out, it would be 0.0000 1, 2, 3, 4, 5, 6, 1, 4, 2. So notice I moved it 7 times. 1, 2, 3, 4, 5, 6, and 7. Okay, don't start thinking, well, hey, if it's a negative exponent, I move it to the left, and it's positive exponent, I move it to the right. That'll confuse you. Okay, and I'll show you why here in a minute. Let's convert to scientific notation. So I need to make a number using the real digits here between 1 and 9.9999. So really, my options are 3,624, 362.4, 36.24, or 3.624, and obviously it's 3.624. My decimal, if I don't see it, starts right here. So going to scientific notation, I get to get my decimal from here out to 3.624. Well, a lot of times in math we have road maps, like this comma tells me I moved 3 spots. So there's 3 spots. Here's 3 more spots. 3, 6, and 3 more is 9. So that means I'm going 3.624. I went from big to small. So my number's getting smaller. So my power has to get bigger. Okay, 3.624 times 10 to the 9th power. Since my number went from big to small, my power has to get bigger. Or I started with a really big number, so my power is big. So here I start with a really small number, right? So my power is going to have to be negative. And I'm dealing with 3.624 again, right? So the only question is, what is my power? Well, I moved it from here, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 to the negative 9. So I start with a really small number, my power has to be small. Start with a really big number, my power has to be big. I start with a big power or a positive power, my number is going to get big. With a negative power, my number is going to get small. Just kind of think of it like that. Okay, let's go ahead and try some of these. So, applying the properties of exponents, numbers, and scientific notation. So really all we're doing here is looking at it. I'm going to rearrange stuff. So this means multiply, obviously this means multiply, but in between here there's also a multiply. So I have 2.0 times 10 to the negative fourth. All the parentheses are doing are holding together scientific notation pieces. So we're not actually bringing anything in, so I'm just going to rewrite everything without the parentheses. And then using the commutative property of multiplication means I can just move things around because I'm multiplying everything. I'm going to go ahead and put the numbers 2.0 and 9.2 next to each other because they're not powers of 10 here, and the powers of 10 next to each other. And what that allows me to do is kind of think of it like this. Hey, I'm multiplying those two pieces together. 2 9.2s is 18.4. And I'm multiplying these two things together. 10 to the negative fourth and 10 to the negative third, well, same base. Negative 4 plus 3, right? So just applying our properties there. Negative 4 and negative 3 gives me 10 to the negative 7. There's a multiply in between, so I have 18.4 times 10 to the negative 7. It says put your answer in scientific notation. So 18.4 is not between 1 and 9.99, so I've got to move that decimal 1 this way. So the number went from bigger to smaller, or I started with a bigger number, okay? Or I got one smaller, so if this number gets smaller, this one has to get bigger. So by taking a place value off there, I've got to put that one back on over here. So it's negative 7. I'm adding it back on, that one I took off there. So that's actually 1.84 times 10 to the negative 6. So kind of the quick route, I mean, I wrote all this out, but hey, just multiply the real pieces together. 2 times 9.2. 10 to the negative fourth times 10 to the negative third. And the same thing really goes with division, right? I mean, you're just dividing the like pieces. So 8.4 over 2.1 and multiplying that by the division of these two. 10 to the second over 10 to the fifth. So 2.1 goes into 8.4, 4.0. It goes in 4 times, but when you're doing scientific notation, you want to put the decimal in the 0. So 4.0 times 10 to the, well, same base. You're dividing, so subtract. 2 minus 5. So 4.0 times 10 to the negative third. This is between 1 and 10, so we're good. The very last one here, we're going to bring in the power of 3. This just says you have 3 of these things. So I'm going to write it expanded just really quick. It says I have 5 times 10 to the negative 4 3 times. All right, now that's really, like, writing that out is pain. So remember, just remember your power properties. It means you have 5 to the third power, right? 5 times 5 times 5. And 10 to the negative fourth to the third power. 10 to the negative 4 to the third. 10 to the negative fourth times 10 to the negative 4 times 10 to the negative fourth. Okay, well, 5 to the third is 5 times 5 times 5, or 125. And 10 to the negative fourth to the negative third, remember, power to power means you multiply those. That's 10 to the negative fourth times 3. So 124 times 10 to the negative 12. And then our decimal is sitting right here. We've got to get this between 1 and 10, so we're going to move it over to not 12 and a half, but 1.25. And since we got 2 smaller, this one has to get 2 bigger. So we're going to have to add those 2 we took off here onto the power. So 1.25 times 10 to the negative 10. Okay, well, I think that's all I've got for you. All right, good luck.